Good afternoon. Welcome to the session on analytical hierarchies. My name is Tim Peterson. I work with SolidQ. I'm based in the United States, in Minnesota, but this year I've had about a quarter of my business in Norway and Sweden. So I have gotten to know a few of the folks out here, and I very much enjoy having the opportunity to come here to Sweden again and to do a little work with analysis services. The topic I'm going to cover today is analytical hierarchies. I'm going to tell you about analytical hierarchies. I'm going to try to persuade you that you really should use analytical hierarchies. And then I'm going to do a little bit showing you how to create analytical hierarchies in a multi-dimensional cube inside of analysis services. I teach MDX, and I can't give you a full lesson in MDX in the session today. MDX is really very easy. I want to assure you about MDX is not hard. Learning Norwegian, that's hard. Learning MDX really isn't that bad. But it does take some concentrated time to learn some of the concepts of sets and tuples and various things. So what I'm going to limit myself today is to show you a few things that if you already are doing MDX, there's a few hints that will allow you to create analytical hierarchies more easily. And so I will be talking a little bit about that. So people say, what are analytical hierarchies? If you search the internet and see if you can find out what analytical hierarchies are, you won't find very much because I kind of made up the term. And what I mean by it is, normally what a cube, think about the whole sense of multidimensionality. Some people live in a world where there are only two dimensions, columns and rows. I can't live in a world like that. That's not reality. The world has multiple dimensions. And when we think multidimensionally, we think about all of our data being together in one big blob, and then we start slicing it and dicing it. Slicing and dicing. Ever heard about that? Slicing and dicing is what we do in multidimensionality. And most of the time with our hierarchies, we are slicing it up into different categories, into different time periods, perhaps into product categories, perhaps into different customers or different geographies where our customers live. But the difference in what I'm calling an analytical hierarchy is that we are getting different slices of the cube, and we're doing it for some sort of analysis in a way different than just subdividing our big blob up into pieces. So that, for instance, an analytical hierarchy would be if we have one column that's showing the actual values, and another column showing the forecast, and another column showing the goal. Because those types of values, it's not really slicing up the whole, it's giving different perspectives of looking at whatever other data that we're looking at. So we can create an analytical hierarchy in a multidimensional cube with a calculation hierarchy. And I actually did think about calling this session a session on calculation hierarchies because that's maybe the way people normally think about this. I'd rather not just limit it to calculation hierarchies because even if you're not using analysis services multidimensional, let's say if you're using tabular or if you're doing using some other format for displaying your cube data, you can still do analytical hierarchies even without doing calculations. Sometimes you can build analytical hierarchy type of information back into the data structure. And maybe there's other ways of doing it. Today, though, I am actually going to focus on calculation hierarchies, on building calculations in a multidimensional cube. You come to a conference like this these days, and sometimes it seems there's more on tabular and DAX than there is on multidimensional and MDX. Well, this session is kind of, this is the multidimensional MDX side. And I've wondered, is it possible, or is it going to be possible to do these sorts of things in tabular and DAX? And I don't really know. I mean, I know that I do not know how to do this in tabular and DAX. That there's a power in doing this in multidimensional cubes that that doesn't really quite seem to be there on the other side, or at least not yet. If any of you have any more insight on that, I would certainly appreciate hearing about it. Because the ability to create calculation hierarchies is one of the very strong reasons today to use the multidimensional side of analysis services rather than using the tabular. And maybe that will not be the case in the future, but there are a lot of things that we can do in calculation hierarchies. If I can persuade you that you want to do this, then you'll be more likely to use the multidimensional side because of the capabilities that are built into it. Okay, I have an example here. There are two ways you could show the trend and goal in an MDX cube. We could create a lot of calculated members, and I've got this set up in Excel here. So here we have a bunch of calculated members, actually some real members, some real measures, and some calculated measures, which, but they're all built into the cube as measures, either as real measures or calculated measures. They're not put into a separate hierarchy. And this is when, when I go around and I see people as how they develop their cubes, I see a lot of cubes that are built like this. So here we have, internet sales amount, internet sales goal, internet sales trend, internet tax amount, and so forth and so on. And how we build this, of course, is that we can have a lot of individual calculations that look like this. I mean, here I have the internet sales trend. I've got this little MDX taking the average, and I'm taking this range of members lagging back 12 months, and I'm averaging that over internet sales. Well, if I'm doing it like this, then I have to build a separate measure for internet tax trend and a separate measure for reseller sales trend, and I'm basically repeating the calculation over and over again for all the measures that I want to use to apply this to. But if I do a calculation hierarchy, I write the calculation once, and it works for all of my measures. And that is, well, it's an advantage in terms of development, in terms of the number of possibilities I have, but it also is really it fits in better with a whole notion of multidimensionality. Because here I'm showing, I've got a column that's showing exactly the same values that I showed in the previous sheet. I mean, here's the one, here's these values. I guess there's some nulls that are showing it, which aren't on the other side. But actually it is the same numbers. But when I have it in a calculation hierarchy, which I've called actual trend or goal, I can take that calculation hierarchy and I can move it up to the columns. So I can show these values side by side very easily. And if I want to, I can take it off the columns and I can put it into the filter. Now, if I want to just see the 3-year trends, I can see the 3-year trends. Or if I want to see the goal, I can just see the goal. But the point of this is, and those of you who have been working with cubes, I mean, you recognize this is using multidimensionality. It's kind of like a lot of people have their measures, whether they're real measures or calculated measures, and they have a whole list of 50 or 100 or 200, or in one case I saw almost 1,000 measures. And they're not fully dimensionalized. I mean, you could make hierarchies out of that, and you could have many fewer measures. In fact, of course, on the other extreme, you can go down and always get by with pretty much just 2 measures. You can have an amount, a financial amount, and you can have a count. And then you could, everything else you do with measures could be made into hierarchies. Now, I don't actually recommend that either, but I do recommend taking a look at your measures and seeing if you could benefit from putting them into hierarchies, because then we can slice and dice with them, as I'm doing here. And if we leave them in the measures, then we are just left with listing them out like this. And so that's one of the reasons why it's good to consider doing this. Okay, I'm going to get back to my slides here. Yeah, and there I have these demos. I was sitting in the session right before lunch with David, and I expect a lot of you are also there. And man, I tell you, he speaks English a lot faster than I'm ever going to speak English. And he also ran out of time. He had far more slides than he was able to go through. And I have a lot of slides in here too. I thought, well, you never want to run out of material. So there's a lot of slides, and you'll get these slides later, and you'll see some of the code samples, and you'll maybe see some topics discussed that I don't even get to. But I hope that'll be useful to have a few extra slides to see how these things work. Okay, most of the time today I'm going to talk about date calculation hierarchies. Sometimes they're referred to as time intelligence hierarchies. There's a wizard, of course, inside of the data tools that creates the business intelligence wizard will create one of these hierarchies for you. Very useful wizard. I recommend using it. I recommend going beyond it, but I certainly recommend using that wizard to become familiar with how to create a time calculation hierarchy or a date calculation hierarchy. That's how I learned how to do this. I started with a wizard. I thought, what in the world did that wizard just do to my cube? And then I learned how to do it for myself. As I've worked with date calculation hierarchies with my clients, I've identified 4 different types of date calculations. And again, this is a division of the world that I made up, but I find it useful. The first type is really quite simplistic, and you can do this first type, the current date periods. You can do this without a calculation hierarchy. In fact, you can maybe do it better without a calculation hierarchy. And I'm going to show you each of these. Just again quickly the relative date periods, to date calculations, rolling averages, and then comparisons, ratios, and projections. But as we look at all of these, there is an insight that I gained from somebody quite a few years ago at PASS, and he said that when he sits down with people and is trying to design a cube, what he does is he says, well, what spreadsheets do the people really use in this company? Because of course sometimes companies have the piles and piles of spreadsheets or piles and piles of reports. Well, which ones do they really use? And then he said he liked to go and sit down with somebody who was using these spreadsheets, and he would look at the little numbers and the calculations that he was scribbling in the margins. And that's what, if you use the calculation hierarchy, a typical cube will give you the numbers, and you can slice and dice the numbers any way you want. But with calculation hierarchies, you can start doing some of these things like this last one, doing a full year forecast based on the data that you're looking at, comparing what we have year to date with what we had last year to date, looking at last year's full sales, and just doing this calculation. So whatever the people are trying to do with their little notes, you want to build into the logic of the cube so that they can see these values and interact with them. They don't have to calculate it every time. They can just see those calculations being displayed, and they can browse with the calculations that are important to whatever is important to an organization. Then also I want to talk about, and I'm going to show the use of multiple analytical hierarchies. And there are times that I've recommended using 3, 4, 5, 6 analytical hierarchies in an individual for an individual organization. And sometimes having these analytical hierarchies interact with each other. And that can get a little complicated to code in the MDX script. But it also can be extremely useful to the users once you all have done that coding and gotten it all ready for them. But the basic case of using a multiple analytical hierarchy I'm going to look at today is, let's say we had, well, what should we say? How about a bicycle company? Let's say we had a bicycle company. And let's say this bicycle company kept track of 3 dates: order date, due date, and ship date. Well, if we were going to be doing these calculation hierarchies, looking at the various, putting calculations, which date should we use? Well, some people would want the order date. Some people would want the delivery date. Well, I say, do it for all of them. And I've had clients where we've actually done this. We've had, about 20 calculations applied to 15 different dates. So each of the users can pick the date that's important to them, and they can look at the calculation for what's ever relevant for them in their particular situation. Okay, back to Excel here. So here is I'm going to show the use of a couple of date calculation hierarchies, and the first one I built is what I call a select date period. And AdventureWorks has a very peculiar data structure in one place where there's an internet sales amount and an internet extended amount, which are exactly the same value in every situation. Now, I don't know why you want to do that, but it's very useful for my little demo here because I am applying calculations to the internet sales amount, but I'm not applying them to the internet extended amount, which allows me through these demos to say, here's what the data looks like with the calculation applied, and here's what it looks like without the calculation applied. And they're exactly the same values, you know, if I didn't have the calculation there. So we're looking at this series of date calculations. They're put into a hierarchy, so I've set them on the rows. But of course, and notice the first one. The first one is a value that I've listed here, a member that I've given the name none selected. This is kind of hard in this business. In using a date calculation hierarchy, I'm not sure what to call the value when I'm not using it. But I've chosen this none selected because there may be times you don't want to use the date calculation, and if I'm not using the date calculation, I'm going to see, well, exactly that. I'm going to see none selected. So if I bring it, if I put it up into the filter box, well, none selected appears there because that's the default. And if I don't pick anything else, that's what I'm going to get. I would, okay, we're going to look at the first category, which is what I call the current date period calculations. And again, as I mentioned before, these are the ones that you really don't have to do with a calculation hierarchy. You can do them easily by adding another attribute into your date dimension, you know, into your data structure, which says is current year, and then have values of is current year, is not current year, or is current month, is not current month, and have separate attributes, one for whether or not that tells you whether or not it's a current year, another one that tells you whether or not it's a current month, another one that tells you whether or not it's a current day. And then, of course, you do an incremental process of your date dimension every day, and you change, you know, whether the values are yes or no as you go through time. The value of this is, and this is really of all the types of calculations, this is really is quite common that people do this, because we want to have an Excel spreadsheet that's going to show me the current year values no matter what the current year is, or a report that shows me the current year values no matter what the current year is, so that I don't have to, I mean, I could be showing product, I could be showing customers, I could be showing whatever in my report, but I'd always be slicing on current year or on current month. Or people do this different ways. I mean, maybe it's the last fully completed month, or whatever you want. So But it's interesting to see how this works if I actually put the date dimension together with it. So I'm going to come in here and find date.calendar and select that. And I really wanted that down in my rows. So that here we see, again, with the date calculation applied, I see values for 2007. And without the date calculation applied, I see all the normal values that are in AdventureWorks. The way I've built this is I actually I'm using the current date here, but adjust it for 6 years back, because then I can do demos for this year and next year, and after that I'll have to change it. But so I get into, so if I drill down into numbers here, if I go into the fourth quarter of 2007, oh yeah, I'm looking at the current year here, but I guess what I really would want to show is if I go over to the current month, then I should just be showing November of 2007 because 6 years ago today is November of 2007. So that's, and I have a, and I do that just inside of inside the data source view. I have a calculated field that uses the getDate function, and so every time I process the date dimension, it automatically looks at what the current date is, and it and so my calculations, and not just this calculation, but of course all the calculations that depend on the current date are built off of that that attribute in my cube. Okay, so this is let's see. I need to collapse this a little bit, and while I'm here, I also want to show how this interrelates to my other date hierarchy, which I have chosen to call date type. So I'm going to put that one up on columns, and so we let's see. We see we have order date, ship date, and delivery date. Now this is all the current month. If I switch over to current year, I get something that now starts, that users could find a little confusing. But of course, anytime you're crossing different types of dates, you know, things aren't going to look, I mean, you have to understand what you're looking at in order for this to make sense. I mean, what this is saying is that this is, if something was ordered, if I'm looking at the order date on the rows, well then, if I'm looking at the order date calculation for the current year, that's going to all show up in the current year. But when I'm looking at ship date for the current year, some of those were actually from the previous year. And, you know, I tell you, I mean, could people get confused about this? Yeah, well, yes, they could. In fact, I tend to get a little confused when I try to explain it myself. But I actually find it easier to look at if I'm going to get rid of date here, and I'm going to pick a delivery date instead, because I don't know, for some reason this one makes more sense to me. So I'll take delivery date and drag that over here. And so what this is saying is that if I'm looking at the delivery date on the rows, some of the values, you know, some of what was ordered in 2007 was actually delivered in 2008. And this is actually a way of slicing and dicing the data that an end user might actually want to look at. You know, what was ordered in one year is actually delivered in another year. And because I'm now, I have delivery date on the rows, I get over the delivery date column, well then it's lined up completely right because I'm looking at delivery date on the columns, I'm looking delivery date on the rows, and so we end up with everything in the same year, which is what we would expect to have. Okay, I'm going to go on and talk about the other types of date calculations, and to do that, I'm actually going to remove date type, because though it's very important to be able to do that, it also keeps making things more confusing. So, and really when I say confusing, in my experience, it's more confusing again on the development side than it is for the end user, because if you get these calculations created and you put them appropriately in reports and or Excel spreadsheets or wherever you're delivering your multidimensional data to your end users, it usually isn't confusing to the user when it's being displayed in the proper way. The second type of period I wanted to look at was what I call the relative periods. And for these, let's see, I'm going to actually remove internet extended amount. We'll just look at the internet amount, and I'm going to put the date period over on the columns, and I'm going to select a few of these. I want to show none selected, and I want to show previous month and same month last year. So that now when we look at the individual months, and okay, a little hard with the resolution here, but we've got date period, 2000, okay. Okay, and here, you know, I'm getting confused because these values aren't lining up the way they should, but here I did the user error, which I just was telling you how easy this was for the user to do, and now I've got delivery date, when of course what I really needed was to have the ship date so that they would line up with the shipping date period, because I needed to have order date, because order date is in fact the default date that I'm going to use. Whenever you have a calculation hierarchy, you need to have a default date selected, and the default date that I've selected to use is order date. Okay, so now we come back in here, and again, I really want that on my rows. And so now when I'm at the year level, I see the previous month value is NA, because how can I have a value for the previous month if I'm looking at years? If I drill down into semesters, I see NA. In quarters, I will see NA. When I get down to the months, then I see the values. Ah, good, it worked this time. I see the values that I want to see. Namely, if I have nothing selected, I'm seeing the current month values. But then in my calculation hierarchy, when I have the previous month selected, then I see the values for the previous month, and you can see them lining up. And of course, it's the same thing for the same month last year. Well, this, of course, leads right into the other types of date calculation, because once I can do this, then I can do things that are more interesting, such as adding in the percent of change from the previous month, or the percent year-to-date change from last year, or finally even down and doing this current year projection, which I already discussed, was I take year-to-date this year, year-to-date last year, and I take the proportion between them, and then I multiply last year's total sales to get what I'm projecting to this year's total sales to be. But that's, I mean, that's just my simple calculation. And of course, an end user will have whatever other types of calculations they really want. Whatever they're scribbling in the margins. Whatever they're scribbling in the margins, you can build into the cube as a calculation. So they always have that information available for them at their fingertips. So here we have the different calculations. And as you notice, when you look at this, like the current year projection, we're looking at the values as they would have been projected at the end of each month for the particular year that we're looking at. So even after a year is completed, we can go back and we can see, I guess this is maybe what people call backcasting or whatever, but we can look back historically and see how did our year-end projections look at any time during the year, which maybe is useful for us as we're looking at the current year and we're projecting out what things are going to be to the end of the year. I mean, if other years they jump around a lot, well then maybe we'll expect that could happen this year too, and so forth. But this is the kind of thing, doing a current year projection or doing a percent year-to-date change, or even doing year-to-date itself, and showing that together with a time hierarchy is very difficult without having a calculation hierarchy like we are using here. I just like to show, I mean, I'm showing all these others. I just think the year-to-date itself is an interesting one to look at real quickly. So here we have, again, none selected. So we're going through the hierarchy with none selected. And if I can back up to the beginning of the year, Adventure Works has way too many levels in the date hierarchy. But if we go back and display the months, we see that if nothing is selected, well then of course for each month we're showing the values that are there for that month. But year-to-date is going through the same thing and is aggregating up from the beginning of the year to the present. Now, of course, I'm doing this here for internet sales amount, but again, always want to remind you that the value of this type of approach, using a calculation hierarchy, is that I can do it with any measure in my cube. And I don't have to write new calculations for it because the calculations are measure independent. And so I hope I've persuaded you to do this. Now, my time is half over, so now I'm going to show you how to do it, or a little bit about how to do it. And going back to my slides, I have a discussion of the different types of date hierarchies in here. And I think I've basically gone through all this, showing it to you in the demo, so I'm not going to talk about these right now. But a lot of what I had just said, you can read here in the slides when you download the slides later. So I hope that is useful to you. And there are some screenshots, again, showing how these different types of calculations actually are displayed for the end user. And there they are. I mean, the good ones, of course, are these comparisons, ratios, and predictions. Those are the ones that really are calculations, when we're really going out and doing calculations. Okay, so here's what you have to do to create a calculation hierarchy. First of all, you have to know how to use MDX to create calculations. And I'm not going to teach you how to do that today, but that is kind of a prerequisite for this. You have to have some sense of MDX. And if you don't know any MDX, don't worry. It's still good for you to see how easy it is to do this. But you will have to go back and learn the MDX before you actually do very much of this. Secondly, you have to learn how to write MDX script code. And I know a lot of you are doing that already, but that's a little different than writing calculations. A lot of the same, all the same principles apply with a few extras. But then there are some basic principles for creating calculations in a calculation hierarchy. There's some pitfalls in doing this. Some typical things that people get confused about, which here's where I can really help you today. If you've ever looked at this or are planning to look at this, there's just some things you need to remember that will make your life a lot easier. And then, of course, well, this fourth thing is kind of what we've been talking about already, is just imagine what you can do with this. You know, find out how the calculations that would be useful in your organization. You know, take a look at your measures and consider how you could collapse those measures and hierarchize them. And really, you know, make your cube, I mean, your cubes are already multidimensional, but you can make them more multidimensional. You can make them so people can be browsing and slicing and dicing in ways that for many of you, I know many of you have cubes now that you could make them more hierarchical than they are. Okay, here are the basics. You created the MDX script. The default member shows the data in the way it would be as if the calculation hierarchy did not exist. And of course, that's that none selected that I used. You have to have a calculation hierarchy has to have a default member. It just, and I'll show you some more about that later. And then of course, all the other members of the calculation hierarchy are in fact MDX calculations. Now, you need a source table for your calculation hierarchy. Actually, you don't. You can create them as members right in the MDX script. Let's say I prefer to have a source table. And though my source table actually often isn't really a source table, it's a query in my data source view, where I just say, okay, I'm going to have these 3 calculations, or actually 2 calculations and my default. My default here is going to be actual, and then I'm going to do a 3-year trend, and then I'm going to do an incentive goal. And the 3-year trend and the incentive goal are going to be calculated off of the actuals. And I put in a key, which is only necessary because I want to sort them in the proper order. I mean, I would nearly always put the default one first. I suppose there could be reasons not to, but I always want to sort things in a particular way. I mean, that's true around cube stuff altogether. So I've set this up, and I did some of the work ahead of time because there's never enough time when you're up front. Here's my in the data source view, I've got my little query just as you saw it on the screen. Got my query behind there, and I created a simple dimension. I mean, this is a simple dimension, but a few things I did with it. Well, if I go to the browser here, you see that this one doesn't roll up. You have to take the aggregations off of the attribute because you can't roll up actual 3-year the 3-year trend and the incentive goal into a single measure. So you have to disable the aggregation for the attribute, and of course you also have to set the default. You have to specifically say, I want the actuals to be my default. So then I come over here and I've already put it into my cube. I've added to my cube. Here it is down here, the actual trend or goal. But here's the thing I wanted to note in particular. Here in SQL Server Data Tools, what used to be called the bids, of course, in the old days. Here's the place where you relate the dimensions to the measure groups. And dimensions are always related to a measure group unless it's a calculation hierarchy. Look at, watch the bottom row there as I scroll over, and note that this hierarchy is not related to any of the measure groups. It has no relationship to any of the measure groups. Now, when I first started doing calculation hierarchies in earlier versions of analysis services, we had to relate it to the measure group, even though it didn't make much sense to do it. But now we don't. Now we just have this hierarchy. It's totally unrelated to the measure group. So when, before we actually start writing our calculation, and I have not done anything with a calculation right now, if we come over here to Excel, let's see, I'm going to collapse this a little bit. Here I have my actual, I have my 3-year trend, and I have the incentive goal. And note that the 3-year trend and the incentive goal are showing exactly the same values as the actual because I haven't done anything with it. And because this hierarchy isn't related to any other dimensions, it's not doing anything. It's really as if this hierarchy did not exist to the cube at all right now. It is in the cube, but it's not doing anything. So the first thing that I would do, what I would say as a good practice, is I would come back and I would initialize it. Now, If you're using it to apply to all of your measures, you don't actually need to initialize it. Here's again, well, a screenshot just for the starting where everything is showing the same. And to initialize it, I use something called scopes. And the syntax of a scope, there's two ways of doing it. One is what we call a direct assignment, and that's what this one looks like. The alternative is to do scoping statements, which is my favorite. These two blocks of code do exactly the same thing. If I can just, even people who write MDX calculations, they come and they start doing this, and it feels a little awkward, when you first start doing it. But if you just interpret what this piece of code says, it says that if I'm at key 20 or at key 30, my two calculations, if wherever that is in the cube, I want the value set to null. I'm initializing it. Because in this particular case, I don't want this calculation to apply to all of my measures. And if it's not going to apply to a measure, I've either got to set it to null, or I've got to set it to NA, or I've got to set it to something. Because if it doesn't really apply, well, I certainly don't want it to show the 3-year trend for something as being the same as the actual. That would really confuse the user. So we have to initialize it unless we are going to apply this calculation to absolutely every measure in our measure group. Every measure in our cube. The alternative syntax like this says, we're going to start by creating a scope. And this scope is, it's another word for a subcube, a portion of a cube. We're going to slice the cube in a particular way. In this case, we're going to slice it on where this calculation hierarchy is at value 20 or 30, at the two calculations. And then we have this funny little statement that says this equals null. And what this means, in this case, this means whatever scope that I'm in. Now, I like doing it like this because scopes like this I can embed within each other, and I can make my code a lot easier for me to read later on. But if I'm using direct assignments like this, I end up getting really long combinations of sets, and it's hard for me to read. But if I do this and I embed them, I can keep track of what I'm doing. And of course, as with any type of programming, you got to keep track of what you're doing. It's very possible to get confused when you're doing this sort of work. So I'm just going to go back here and go over to my calculations here. And this is where the reading glasses have to come out. And this is exactly the same as I showed you on the screen. And now I'm going to uncomment this block of code, and I'm going to save it. And hopefully it's not going to ask me to reprocess the cube or any crazy thing like that, but it really shouldn't. And go back over here to Excel. Oh yeah, it's coming. It'll be there in a minute. But going back, remember, this is what we're looking at right now. The actual, the 3-year trend, and the incentive goal all look exactly, absolutely the same. Okay, it's finished now. So if I refresh, now the 3-year trend and the incentive goal got blanked out because that's what I said. Wherever it's this 3-year trend and incentive goal, I want to show null. And so it shows null for internet sales amount. It shows null for the internet extended amount. Now, so the second step then is to do what I call building a template. I get confused writing code. And one of the problems that I have in writing code, and I've seen other people have the same problem, is that sometimes you try to do too much at one time. You just, I got to do this and this and this and this. I got to handle this peculiar situation and that particular situation. And so what I've learned with MDX scripting and MDX in general is I start with a template. I start with something very, very simple. And here is my template for the initial calculations. The first thing is I set up a scope that says I want it to apply to these calculations. Now, if I wanted to apply to every calculation in my cube, then I skip this step. Because, I mean, what this is, it's limiting. I say I only want the calculations to apply in this, whenever these measures are being browsed. Okay, the second part of the template is I just make a simple assignment. I say, okay, I'm going to be handling each of my calculations separately, so I set up a scope for each of them separately. And I start by just saying this equals 20 and this equals 30. Then I have end scope statements. You know, scopes get embedded inside each other. When you embed scopes, you know, the outer scope, the inner scope piles on top of the outer scopes and so forth. And yeah, not too hard, I hope. I guess the goal is to try to not make it so hard. But I find it really useful to set up this template first because you know, that in itself is a fair block of code to write, and it's nice to be able to get that working. So I've got that here, and I'm uncommented, and I'm going to save. While we're waiting for it to save, look at it one more time. We start with the outer scope, whatever measures we want to apply it to. Oh, and by the way, if you do run the BI wizard, the intelligence wizard to add time intelligence to your cube, you will get code that looks very much like this. Okay, so then we make the simple assignments, and we should be ready to go over here. Come over to Excel and refresh, and so we have our 20s and 30s, and you know, it's kind of interesting how this looks. I mean, it looks a little odd that the values are 20 at the quarter level, they'll be 20 at the month level, they'll be 20 at the day level. Because what we said is, if ever somebody is browsing on the 3-year trend, we're going to show 20. And if ever you're going to show the incentive goal, we're going to show 30. And so, and then we come over a little bit farther, and we see here for internet extended amount, we still see the nulls. Because we didn't apply this. We don't want to apply that. And we always want to check that. You always want to make sure that you're not applying your calculations in places where you don't want them applied. Okay, the next step then is to make assignments by level. And really this is continuing to build the template, because often when we're working in a date hierarchy, we have to do different things at different levels. And so, I mean, you maybe don't want to do something for every level, but and you maybe want to do it for some. So here, we just continue on, and we continue our scoping at another level of embedding. So again, the first level is what measures we want us to apply to. The second level is which calculation are we looking at. The third level of embedding is which level are we looking at. So here I'm saying we want it to apply to all the fiscal quarter members. So we come back here, and now I have to, or it would be wise for me to make sure this works right. I need to comment out the block of code that I was using, and okay, so get rid of that one, and we'll now have our embedded scopes that are bringing this down to the levels. So we say, show that, and save it. So again, very much, you know, not that much different from what we did previously, but now we're only going to apply the 20 at the fiscal quarter level. Now, this is interesting to see how this looks and how this is different from the previous state of it. And here we show 20s and 30s at all levels. Now we refresh off. Now we get down to the day level and the month level. Let's see, I'll get rid of the days. But we show the months. We don't show anything because, you know, we initialize to null. So everything's going to be null unless we set it to something else. So days and months are going to stay null because we're making this assignment of 20 on the quarter level. And so we see for the quarters, in fact, that we have 20. But when you make assignments in the MDX script, higher levels are always recalculated. In fact, what the server does is it makes an additional pass through the cube and re-aggregates up to higher levels, which is one of the reasons why you do nearly always have to assign some levels separately, because it doesn't often make sense in a calculation to take the value at one level and apply it up to a higher level. So we're showing 20s for the quarters, which is what we assigned it, and we show 80 for the year, and so forth. Okay, then the next step is to this is, of anything I'm going to say in terms of development, this is the part that, listen to this. This will save you a lot of headaches if you're doing this. And that is that you almost always, I probably should say always, you need to include the default member of the calculation hierarchy in your calculation. Either directly, or you have to have an indirect reference to it. You have to reference another member of the calculation hierarchy which references the default member. If you don't, you get an infinite recursion error. And sometimes that shows up as, it sometimes shows up like this, with an error message. And this is what I like, and the message which I've highlighted here, infinite recursion detected, loop of dependencies, and so forth. I like it when this shows up in error. Unfortunately, often in Excel or in other client tools, this will show up as null values, and it just will disappear. And that, to me, is a lot harder, because there are a lot of reasons you can get null values out of a calculation. But if I see this error and I'm told that it's infinite recursion, well, why is this infinite recursion? I'll take a look at this calculation. I'm saying that for the quarters, I want to show the average of the previous 12 months with whatever the current measure is. Now, what's the matter with that? It looks like a reasonable thing to say, except that if we are browsing here with a 3-year trend and the incentive goal, you have to think about how multidimensionality works. If we're here with we're selecting a column with a 3-year trend, and so if we only want to see the portion of the cube for the 3-year trend, and we come into a calculation like this, it's showing the current member, the current measure. It's going back 12 months. It's taking the average, but it's taking the average of the 3-year trend. And there isn't anything for the 3-year trend. It's null, because we haven't assigned it a value. So it tries to call itself and results in infinite recursion error. Here is the corrected code that we have to add in this reference to this line to key number 10, which is the actual. So what this is doing is taking a cross join. It's taking the actual value for the previous 12 months with whatever the current measure is, and is going to average those values. Now, just please, if you're going to do this, get these slides and take a look at those 2 examples and study them, because there are a lot of folks, including myself, when I tried to do this, I've written code that looks like this, and it looks like a perfectly good calculation, but I've just forgotten to include the actual value in there. And if you don't start with an actual value, you're not going to get anything. I hope that makes sense. I know when I teach my MDX classes, I have to go over this several times before it sinks in. But if it doesn't make sense, at least don't forget it, because it will be something that you will need to use. Okay, I'm running down to 7 minutes here, and I have a lot of slides, which I'm going to go through quickly. I have just a few comments about the BI wizard. I like the BI wizard. It builds you a good time calculation hierarchy. If you want to start with a time calculation hierarchy, use the wizard. Get the code. See that, pick all the calculations, and it'll write you this code for it. And then you can extend it and build on it to add whatever calculations that you would want to use. the BI wizard adds a hierarchy to the selected date dimension. It'll only do it for one date dimension, and you know, I prefer to have my calculation hierarchies as totally separate dimensions. It's much more flexible and I think easier to understand. But certainly the BI wizard is a very good tool. I encourage using real members for calculations. I have a few, just a process list going through here. Steps for creating a customized time calculation hierarchy. You write the name query in the data source view to create the members you want to have. Include a field for the key and the name, as I showed you. Create the dimension for the hierarchy. Set the default member of the hierarchy. Set the is aggregatable property of the hierarchy's one attribute to false. I mean, this dimension just has one attribute hierarchy, and you don't want it to aggregate because calculations don't aggregate. You add the dimension to the cube. You don't add it to any measure groups. It doesn't belong in any measure groups. You do the scope block in the MDX script, including all the measures you want to use to assign the calculation. And then you have the embedded scope blocks for each of the members of the hierarchy. I see I did actually miss the initializing step in here as I made this list. So do remember to null out the measures that you don't want to have a calculation applied to. And then finally, assigned formatting is necessary. I found analysis services to be a little peculiar in this way, that sometimes my calculations come out with good formatting, and they sometimes don't. So what I've found is I just, okay, after I'm done writing all my calculations, then I'll go and I'll write code that assigns the proper format, whether it's currency or number or percent. And I have a few slides here on determining the current date. I mean, you can do string to member and do this calculation using VBA MDX, using the now function. I don't really like that method. One method I've used in some places is that we add one date into the cube every night and we reprocess. So I always know that the current date is either today or yesterday. Well, no, current date is always today. That's right. The current date's always today. Sometimes depending on the situations, yesterday is the most current date that we happen to have in the cube. So that's a possibility. The third way, which I described earlier, is just to have an is today attribute in your date hierarchy, and that can be calculated. It could actually be put in the source table, and so then you do an incremental update in your date dimension, so you have a solid place to start with when you're doing date calculations of what today actually is. And here's the implementation that I've used for these demos. That I just as a calculated member in the DSV, I do get date, and I subtract 6 years from it, so it brings me into the AdventureWorks range of reality. And so then I have, whenever I'm doing a demo, I have today's date 6 years ago in AdventureWorks. Okay, and then I have samples of code. Here is the code for the current date period, and shows how to calculate that. I have several slides of that. I won't go through this, but again, you can get these slides, which hopefully will help you as you're trying to do these things. For a relative period, this is for the code for the previous month. And again, it all follows the same pattern. In this code, I'm initializing to null. If I initialize the whole thing to null, that really wouldn't be necessary. But then I start with date.members, and then I do the month.members, and then I do quarter.members, and then I do semester.members, year.members, and finally all periods. Because for some of these calculations, some of them will work without doing all the levels, but a lot of them you have to do all the levels in order to make things show up correctly. And what I like to do on the higher levels, normally a best practice in MDX, if something is null, you should leave it null. You shouldn't set it to 0 or NA or something like that. But that's not best practice in a date calculation hierarchy, because if you set higher levels to null, say like a 6-month rolling average, and you try to drill into that hierarchy with Excel, you're going to run into nulls, and it's not going to display anything, and you're not going to be able to drill down. And that happens with a lot of client tools. So I consider best practice on higher levels of a date calculation to put something like NA, because it doesn't apply. And 6-month rolling average does not apply on the year level, and so you should be showing NA at the year level for that. And there's code here that shows how to make that happen correctly. And what I do is I like to show NA in places where there is a value at the lower level, but if there's not a value, I want it to be null. And this is the sample code does that. And I have code in here for a ratio. I have code in here for assigning formatting, which is what I do at the end. And then once more, I told you about analytical hierarchies. I showed you how they can be used, and I hoped I persuaded you to use them. There's a lot of value in what you can apply, what you can give your clients, and give your customers by thinking about what sort of calculations you can build into your cube. And I've given you a little class on how to create them. So I think we're about out of time. If there are any questions. Oh yeah, and if anybody knows how to do this with DAX, let me know. I'd like to see that. And really, I'd like to know if Microsoft is planning to put that in a version. I mean, that would be very helpful to me as a consultant to understand that. But for now, doing the calculation that appears on for different rows for different dates, this is the tool that we have to do it. So thank you very much.